I want to use this example to explain how to compare two proportions. So in this example, to study the long effect of preschool programs for poor children, the High Scope Educational Research Foundation has followed two groups of Michigan children since early childhood. One group of 62 attended preschool as 3 and 4 years old. This is a sample from population 2, poor children who attend preschool. A control group of 61 children from the same area and similar background represent population 1, poor children without preschool. So basically for this problem, we have two population. We have one, we have two, right? Okay, and so the sample size. So N1 is 62 and N2 is N1 is 61 and N2 is 62. One variable of interest is the need for social services as adults. In the past 10 years, 38 of the preschool sample and 49 of the control sample have needed social services. So basically, so X1, so this is 49 and X2 is 38. Okay, so the question is, does the study provide evidence that preschool reduces the later need for social services? So clearly, so let P be the proportion of people who need social services. So we need to identify non and alternative hypotheses, right? So first we identify alternative hypothesis, yeah, because this should be the thing that we want to find evidence for. So we want to find evidence that preschool reduce the need for social services. Yeah, so basically it just means P1 should be greater than P2, right? So P1 means the children without preschool, and P2 is the children with preschool. Okay, so the null hypothesis will be P1 smaller than or equal to P2. Okay, so let's first try to calculate test statistic. The Z0, okay, so if you copy the formula, and so will be basically P1 hat minus P2 hat square root of P hat 1 minus P hat times 1 over N1 plus 1 over N2. Okay, so let's see what they are. P1 hat, P2 hat, so they will be the sample proportion, right? So let me erase this. Okay, so P1 hat, P2 hat, right? So basically P1 hat, so will be X1 over N1 will be 49 over 61. And so P2 hat will be X2 over N2, right? So will be 38 over 62. So they are just the sample proportion. And about this P hat, P hat will be just suppose we pull population 1 and 2 together, and so the probability we get is called P hat. P hat you can see so will be 49 plus 32. So those are the total number of persons who need social services, right? And so the total sample size is 61 plus 62. Yeah, so essentially to get p hat, we combine population 1 and population 2 together. Okay, yeah, so this is equal to 0.707. Okay, and so then you can plug in. Okay, so P1 hat, P2 hat, 49 over 61 minus 38 over 32 square root 0.707 times 1 minus 0.707 times 1 over 61 plus 1 over 62. Yeah, so this 61, 62 just will be N1 and N2, so will be the sample size for these two samples respectively. So then you do the math and you will get the statistic 2.317. Okay, and so then to get the p-value. So p-value here so will be probability that basically z greater than 2.317. Yeah, so this number is just the test statistic we calculated, or greater than or equal to, sorry. Yeah, so here and we need greater than or equal to, yeah, because the alternative hypothesis is P1 greater than P2, right? Yeah, see, basically, so these two signs should have the same direction, okay? And so this value you can use as a normal table, or you can just use Excel, okay? So this is 1 minus norm dot s dot dist. So the value is 2.317 comma 2. Okay, so then you will get the p-value. So p-value is 0.013, sorry, 0.103. Yeah, so you compare the p-value with alpha equal to 0.05. Okay, and so p-value is smaller than alpha, so then we reject the null hypothesis. Okay, and so then we will claim the alternative hypothesis, right? So we will claim the preschool will reduce the need for social services. Okay. So now, if we want to calculate a confidence interval, so 95% confidence interval, okay? So the confidence interval will P1 hat minus P2 hat plus minus a critical value from normal distribution times standard error of P1 hat minus P2 hat. Okay, and so in this case, the standard error P1 hat minus P2 hat, so will be square root, so P1 hat times 1 minus P1 hat over N1 plus P2 hat times 1 minus P2 hat over N2. And we've already identified what is the value for N1 and N2, right? I mean for P1 and P2. Okay, so you plug in the value, right? And so this will be 69, I mean 49 over 61 times 1 minus 49 over 61 over 61, right? And so then plus 38 over 62 times 1 minus 38 over 62 times, divided by 62. Okay, so then this will be the standard error. So then you do the math, and so the value will be 0.0801. So this is the standard error for the difference of proportion. Okay, and so then the next will be for this critical value, right? So the critical value you get from Excel norm dot s dot inv 0.975, and you will know, so this is 1.96. Okay, and we've already identified all of the values, right? So this confidence interval will be 49 over 61 minus 38 over 62. So this is P1 hat minus P2 hat plus minus critical value 1.96 times standard error. Yeah, standard error we just calculated here. So 0.0801. Okay, yeah, so then you do the math, and so then you will get the confidence interval will be 0.190 to you will get the confidence interval will be 0.033 to 0.347. Yeah, so then this will be the confidence interval for the difference of proportion.